Hey everybody, welcome to homework number 5, practice number 1. Alright, we will start with what we know, the knowns of the problem. So we know that an inventor has given us a turbine claiming that it outputs 26.19 kilowatts of power. He tells us this happens at a wind speed of 10 meters per second. We know that the density of the air at this time is 1.225 kilograms per meters cubed, and that the radius of a turbine blade is 4 meters. We've been asked to find, is this possible? So this inventor is claiming these things. Is that even a possibility? Is he even telling the truth? Okay, so how are we going to do that? What is our approach here? Well, remember in class we talked about the Betz limit, which is if we write the turbine power equation, the power out of a turbine is equal to our power coefficient times 1/2 rho area of the turbine times the velocity of the air cubed. This is our power equation. And we know that the Betz limit states that CP must be less than 0.593. We can't be any greater than that. That is a physical limit. So you can see that we actually know a lot of this information, right? We know PT, we know V1, we know the density of the air, and we can find the area of our turbine using the radius of the blades, which means all we got to do is solve for CP and see if it's physically possible. So first we're going to do the analysis part of our problem. So the area of the turbine is just going to be equal to pi times the radius of a turbine blade squared. So that's just pi 4 squared, which is just going to be equal to 50.26 meters squared. All right, so now we can plug that in right there. We already know these other terms, so we plug them all into this equation, and we get 26.19 is equal to CP times 1/2 times 1.225 times 50.26 times 10 cubed. Rearranging, we can solve for our power coefficient, which is 0.85. Now I didn't write out units here, but if you go through and check my work, you'll see that all of the units do agree. Oh no, I lied. Sorry. I totally lied. This right here, and this was a trap, needs to be put into watts, 26,190 watts, because this is then kilograms per meters cubed. This is meters squared. This is, let's see, meters cubed per seconds cubed. And so I will invite you to play around with the units here, but you see that all of these units together, so these cancel and this cancels, giving you kilograms meters squared per second cubed. See as your own exercise if you can get this into watts. It's fun. Okay. All right, well, there you go. So we got that our power coefficient is 0.85, which means it is not possible. Okay, thanks for watching, everybody.